video has its purpose to go over the product and quotient theorems for complex numbers. So we're going to start with the product theorem. If you have two different complex numbers and you multiply them with each other, that means you're going to multiply their absolute values and add their arguments. Remember, the arguments are thetas, right? So you're going to add their arguments and you're going to multiply their absolute value. So in a long format, you write it like this. And in a short format, if you use CIS, which stands for cosine of theta plus I sine of theta and so on, you write it like below. So with that being said, let's kind of do some examples and, we'll learn it by doing. So I'm going to leave this available so you can see it in front of your eyes. And let's look at the very first example. We have two numbers. And those are 4 cosine of 120 plus I sine of 120 and 5 cosine of 30 plus I sine of 30. So they ask you to use the product theorem and write the answer in rectangular form. So the first thing we're going to do, we're going to multiply 4 times 5. Right? Those are the R1 and R2. We're going to open the bracket or the parentheses and we're going to say, okay, cosine of, and I'm going to add the arguments, and they are 120 and respectively 30, so plus 30. And then plus I sinus of the same thing, 120 plus 30. Please make sure you keep all the parentheses correct so you don't lose anything. Okay, what do we get next? That's 20. And now we're going to have cosine of 150. And then plus I sine of 150. Okay, now we are not done because you are asked to write it in rectangular form, meaning that I have to use my unit circle to get the values for cosine and respectively sine of 150. Right, so if you look at this, this should be in quadrant 2. So what do we get? Here we go, 20 times. Okay, let's see what it is. Cosine will be a negative, so this is negative root 3 over 2. Plus I, sinus will be positive, and this is 1/2. We're going to distribute our 20. Yeah, so 20 is your common factor that gets distributed. And then we're going to simplify this. So 20 and 2 will get simplified and will be a negative 10. And then root 3, that was already there. And then 20 and 2 also simplifies again, and you get plus 10i. So here's your final answer, this particular problem. And this is how you apply the product theorem. Very well, let's continue to our next example. So before we go in the next example, here's the quotients theorem. In other words, you're going to have two different complex numbers and you will have to divide them, right? So when you have a division line between them, you will divide their absolute values and you're going to subtract. You're going to absolutely subtract their arguments. So that's the long format that you see. And then the short format, it looks like that. Very good. So let's go ahead and do an example on that one. I'm going to leave this here so you can see it. So what do we have here? We have, it's written down in a short format. So you have 27 CIS 45 divided by 9 CIS of negative 180. So let's go ahead and write this by using the theorem. So we have 27 over 9. Now we're going to open a bracket. And we're going to say cosine of, and here we really need to pay attention to our signs. So theta 1 is 45. Great. We're going to write it down. Now in the theorem, there is a minus right there, right? So we're going to copy that minus because you're going to have to subtract it. That comes from the division part. And now I'm going to pay attention to what my next angle is, which is negative 180. So that's typically where probably they get you, if you forget about the signs. Then we're going to say plus I. And now we're going to have to deal with a sinus. It's the same thing, right? 45 minus negative 180. And close all the parentheses and all the brackets. Very good. Now we're going to continue. So 27 divided by 9 is 3. And now if we look here, right, a negative in front of a negative, this becomes a positive, and so is that one. Hence, your number is 45 plus the 180, which is what, 225. So you have cosine of 225 plus I of and sine of 225. Now, if we write it the short format, right, it's going to look like 3 CIS 225. Yeah. They ask you to write also the answer in rectangular form, so let's go ahead and continue then. Please use your unit circle. Yeah. So now cosine of 225, this is your multiple of 45, so cosine is negative. This is in quadrant 3, so we're going to have negative root 2 over 2 minus I root 2 over 2. Very good. Now, if you distribute that 3, just to make it nice, it's going to end up being negative 3 root 2 over 2 minus 3 root 2 over 2 times I. Very good. And this is the answer for this example. I'm going to also highlight a little bit what we got there first in a short format. Very well. We have one more example in this particular lesson. So let's go ahead and do that one. So these are a little bit more complicated and you have to use a calculator. So those are not necessarily easy. I mean, it's not something you can extract out from the unit circle directly, right? Because you have angles that they are not your principal angles on the unit circle. So let's look at part A. I'm going to cut this page in half just so I stay organized. Here it is. Okay, so we're going to look at the first one and we will use a calculator as well. So let's see what do we get here. So we're going to multiply 2.8 at 5.4. Let's write it down, not skip steps. All right, so 2.8 times 5.4. Now I'm going to write them in a short format, so CIS. And now I'm going to look at the angle. This is a product, meaning that I'm going to add the angles. So 38.5 plus 74.5. Very good. This product right here, let's see, I'm getting 15.12. I'm going to open up parentheses now and open up this a little bit. So cosine of, this is, let's see, 113, yeah, plus I, sinus of 113. Let me make it more clear here. So there we have it. So now you have to use a calculator. They don't tell you, or they don't specify how many decimals, but keep at least 4 decimals. So let's get our 15.12 stays. Now cosine of 113, this should be a negative number, and it is negative 0.39. I'm going to get more than 4 decimals for the first part. So 3907 311 285. I got them all here, whatever I saw them. plus I. And now if you look at sine of 113, I'm going to put that in a parenthesis, so that would be 0.92050 485 35. close the first parenthesis, close the second parenthesis over the whole number. Okay, now if you distribute your 15.12 across each term in a parenthesis, now I'm going to only keep 4 decimals. So I'm getting negative 5.9079 plus 13.9180i. And so this way we put the answer in rectangular form. Feel free to round it if you want to, but it depends on your homework. If it's done online, they may specify how many decimals and such. If they don't, feel free to keep 4 decimals. Okay, let's look at part B. So in part B, you have a division. In part A, we had a multiplication. Same idea, you would like to use a calculator for this. So we are getting 1137 over 3.79. Yeah, that's applying the theorem. Now you open a bracket and you go cosine, and I'm going to subtract the arguments this time. So the top argument is 5 pi over 6. Bottom argument pi over 4, so minus pi over 4. Okay, and then plus I sinus of the same thing, 5 pi over 6 minus pi over 4. This is great. All right, using a calculator, 1137 divided by 3.79 is actually 3. I'm going to open a parenthesis and I'm going to look here. So the common denominator seems to be 12. So I am going to multiply the first one by 2 and the second one by 3. It's the same thing for both. So if you do it for the one argument, it will be identical for the other one. So let's see, that becomes cosine of 5 times 2, 10. So 10 pi minus 3 pi, that becomes 7 pi over 12. So plus I sine of 7 pi over 12. Now, using a calculator to actually depict these values, and keeping as many decimals as you can in a first trial here. So cosine here is a negative number, looks like. Make sure you set your calculator in radians. So 0.258819,045. I keep the last one, plus I times 0.96, 59, 258, 263. I kept all the decimals. Great, now you're going to distribute a 3 across. Right, that was your common factor, so it gets multiplied with each factor in a parentheses. And I'm going to keep only 4 decimals now, so negative 0.7765 plus 2.8978i. So here's your answer. It is in the rectangular form. And this is how you apply these theorems. You're going to practice more on your homework. But that's it about this lesson. Next video will be 8.4. So thank you so much.